Hello everyone. In the last video, we introduced how to create a linked list and traverse through each node to print its value. In this video, we are going to introduce another way to traverse a data structure, which is recursion. Okay? When we talked about function earlier, we might have briefly mentioned recursion. Recursion happens when a function calls Excel. This mechanism works similarly to a loop, but if we don't control the conditions properly, it can turn into an infinity loop. Okay, so when should we design a function that calls Excel? I have listed a few key points. If the data and the way we process it meets these criteria, then recursion might be a good fit. The first one is each data node has connections with directional or hierarchical relationships. And the next one is the processing must go deep down to the bottom layer, then return layer by layer to complete the task. Okay, let's take a look at an example. This diagram shows a binary tree, a structure often discussed in data structures. Each node can have up to two child nodes, one on the left and another one on the right. Okay? Now, suppose we want to traverse these trees using in-order traversal. How should we do that? In-order traversals means that the left subtree is visited first, and then followed by the middle node, and finally the right subtree. Okay? Each subtree is also visited in this exact order. For example, if we traverse it in order, the output will be 4, 2, 5, 1, 3. Why? Because we first go to the left subtree, then all the way down to the leftmost leaf node. After print its value, we return to its parent, print that value, and then move on to the right child node. Okay? Repeating the same pattern throughout the tree. Now let's look at the code. I have written a function createTree that constructs the exact binary tree we just mentioned. If you want to see how the function works in detail, I will scroll through it slowly here. You can pause the video and take a closer look. Or you can try building the tree structure yourself. Okay, let's briefly review the node structure. It contains two pointers, left and right, which point to the node's children. Back in the main function, we declare a root pointer and call our createTree function to build the binary tree. Now, how do we design our recursive traversal function? Okay, so first, we declare a function as traverse. Okay, and we only need to pass a pointer to a node as the parameter. Nothing more. Okay, and then we process according to the order we mentioned earlier. Okay, the first thing we need to do is to check if a left child exists or not. Okay, if so, then recursively call the same function on the left child. And then print the current node's value. Okay, and the last one is if a right child exists. Recursively call the same function on the right child. Okay? And there you have it. Our recursive in-order traversal is complete. Back to the main function, we call the function and pass the root pointer as the parameter. Okay, let's run the program and see the result. Perfect. Okay, in this video, we briefly introduced the concepts of recursion and when it is useful. In the next video, we will cover C++, STL data containers. See you in the next video.